Hello everyone, my name is Arohi and welcome to my channel. So guys, in this video I'll show you how to install PyTorch and TorchVision on Jetson Nano. After that we will learn how to set up and run YOLOv5 on Jetson Nano, and we will cover how to use the pre-trained weights which are trained on COCO dataset. I'll show you how to use that pre-trained weights and test on various input sources. We will see how to work with CSI camera, USB cameras, and then how to work on images, videos, RTSP streams. All these things I'm going to show you today. And guys, I'm assuming that you already have Python installed on your Jetson Nano and pip is installed, and after that OpenCV is also installed on your device. So if you don't have these things with you right now, before watching this video I would recommend to install all these things first, and you can check this video. This is the third lecture on Jetson Nano, and in this video I have explained how to set up your Python environment, how to upgrade the pip, and how to install the OpenCV with CUDA compatibility. Okay, so check this video for that. So now I'm assuming that you have all these things in your Jetson Nano, and let's start with the today's class. So first thing is we are installing the PyTorch. So now guys, one thing to note over here is that we can't install PyTorch using pip because on this Jetson Nano. Okay, so we have to manually install this pre-built PyTorch pip wheel, okay, and then from the source only. So let's see how to do that. So let me open the link from where you will install it. Okay, this one. So I will share this link in my description section. Okay, so from this link you will pick the PyTorch version as per your Jetpack SDK version. Okay, so Jetpack SDK version is the Jetpack which is installed on your Jetson Nano. Remember, at the time of initial boot you downloaded the image of a Jetpack SDK, then you flash your SD card with that Jetpack SDK and you installed that, boot your Jetson Nano, right? So that version, that Jetpack SDK version, you should know the version, and on the basis of that version you will install the PyTorch version. So in my case the Jetpack SDK which I am using is 4.6.1. so I am showing you today's class on the basis of that Jetpack SDK. Okay, so you can see here the different PyTorch pip wheels. Okay, let's click on the first wheel first. So you can see here that Jetpack SDK 5 is supported, and then 5.1 and 5.2. So that means if you are working on Jetpack SDK 4, this PyTorch 1.12 version is not for you. Okay, now let's check this PyTorch version 1.10.0. Here you can see that Jetpack SDK 4.4, 4.4.1, and then 4.5 and for 4.6. So my Jetpack version is 4.6. so that means I can install this PyTorch version 1.10, but I have installed this one. There is no specific reason guys. So what I have done is I have checked this PyTorch 1.8.0 and it was compatible with 4.6, so I have directly installed it. I didn't check the above versions. Okay, so but in your case you can go with this PyTorch 1.10 also if you are using Jetpack SDK 4.6. all right, and okay, so this is the version which I am installing. Right now, once you know the PyTorch version which is compatible with your Jetpack SDK, okay, then scroll down and under this instructions click on this installation. Here you can see the installation. These are the steps. These 4 commands will install the PyTorch on your Jetson Nano. Okay, so what you need to take care over here is that in first line, in this line, just move it like this. Over here you have to write the wheel file name which is compatible with you. For example, in my let's suppose if somebody is installing this 10 version, then this is what you need to copy from here and replace this with that wheel file. Okay, this is what you need to do. All right, once you've done that, then you just copy the commands from here one by one. Okay, these are few modules, second line, these are few modules you need. Just copy this command from here and put it on the terminal and execute it, and then again install the Python and then install this. Okay, these 4 lines, these 4 commands will give you the PyTorch. Okay, now you have the PyTorch version, you need a TorchVision for that. Okay, so for every PyTorch version there is a different TorchVision version. Okay, so in my case my Torch version is 1.8.0. I have to download and install the TorchVision which is compatible with it. So let's scroll down, and under this TorchVision you can see we have set of commands. You have to execute all these commands one by one. The only thing to take care is that over here version. Okay, so over here you need to write the TorchVision version which is compatible with your PyTorch version. So in my case the PyTorch version is 1.8.0. Now how would we know that which is the compatible TorchVision version with that? So scroll down for that. Over here you will see a list of versions. This TorchVision version is compatible with this PyTorch. So in my case my PyTorch version is 1.8. So that means the compatible TorchVision version is 0.9.0. So I will install this version. So copy this version from here, and then while installing the TorchVision, these are the 4-5 commands. First, here you need to replace this with your version. So in my case 0.9.0. So you will write V 0.9.0. okay, and over here after that when you are here to execute this command, over here you also need to mention the TorchVision version 0.9.0 and then install setup and then cd to this and then install this command. These few commands will install the TorchVision. Okay, so that's it guys. This is how you install PyTorch and TorchVision. Now we have to see, let's verify the installation, if this installation is correct or not. So for that what you can do, open the terminal. Let's open terminal and open Python shell. So the Python version I'm using is 3.6.9, and guys you get this Python version by default, and NVIDIA recommend to use the default Python version. So if you are planning to work on a Python version higher than this, so let's say you want to work on Python 3.8, then you can install the Jetpack SDK 5. In that you will get a Python 3.8. okay, so but if you're working on this Jetpack SDK 4.6, so as per NVIDIA they say that work on the default Python versions only, otherwise there will be a problem in you can face problems. Okay, so this is my Python version. Let's import Torch. So once it imported, and after that what we can do is we can copy this command from here and paste it here. So you will get your PyTorch version. So my PyTorch version is this. That means I've successfully installed the PyTorch. In the same way, let's import TorchVision. Import TorchVision. After that, let's check the TorchVision version. So you can see here that my PyTorch version is this and TorchVision version is this. So we have successfully installed these two things. Now the next task is to run YOLOv5 on Jetson Nano, because YOLOv5 works on PyTorch framework. So we have the PyTorch with us. Now we can directly work with this YOLOv5. Let's see how to do that. Okay guys, so for that I have this Jupyter notebook. First step is, steps are similar the way we work on our Windows machine or Ubuntu machines, the same way we are going to work on this also, right? So the first step is to clone the GitHub repo of YOLOv5. So this is the official GitHub YOLOv5 repo. So we are cloning that. Once you clone that, you will get a YOLOv5 folder. Okay, let me open my folder location and show you. So here I'm working. This is the YOLOv5 folder. Okay, this you will get after cloning. And now you need to get inside this folder from here. CD YOLOv5. Once you enter in that folder, okay, this is one command which you have to execute. Sudo apt install this command. Okay, this is the few requirements you have to install it. So install this command. After installing this command, you have to install the requirements.txt. But guys, remember, in this requirements.txt file, they have mentioned the PyTorch and TorchVision version also. But we have already installed it, right, manually. So we will delete those versions. Okay, so let me show you. So see, in this YOLOv5 repo, you will get a requirements.txt. Let's open this file. Now, when you open this file, here you can see the Torch and TorchVision version. Okay, so but we don't want to install these things because we have already done these two steps. So you can delete these two things from here, and then you can, after deleting this, you can run this command pip3 install -r requirements.txt. This file will install all the other requirements of YOLOv5. Alright. Then after that, what we need is, we need the pre-trained YOLOv5 weights, and that what we are doing here, we are downloading the weight file. This weight file we want to download, right? So we are downloading it from the official YOLOv5 repo, and you can see, okay, let me show you. Alright, you can see over here. Once you execute that, this command, okay, you will get YOLOv5s.pt file. .pt means PyTorch model. Okay, so this is the pre-trained PyTorch model, and it is trained on Coco dataset. Pre-trained Coco model is this. Okay, now we are checking the OpenCV version. So I'm using 5.1, and after that I am using the detect command. So guys, this Python detect.py, this detect.py, you will get all the files and folders inside this YOLOv5 repo. Once you clone it, you get over here, right? So this detect.py file is responsible to perform the detections on various different sources, like how to it will it have a code. It will accept the source, input source, USB camera, RTSP streams, images and videos. Okay, this file don't have a code which supports the CSI camera. All right, so that code, that part we will add ourselves. Don't worry, I'll show you that part in some time. First, let's see if this Python, this detect.py is able to work on images, videos, USB camera and RTSP streams. Once we test all these four sources, after that finally I'll show you what and how to add in, what code to add and where exactly to add that code in detect.py in order to work on CSI camera. Okay, so let's see. So initially I'm starting with the source image. So Python detect.py, and we are providing the source. We want to perform the detections on this image, and which weights file we want to use. The weight file we have downloaded just now, the pre-trained weight file. Using this we want to perform the detections, and once you execute it, you will get your results stored in runs folder. Under runs folder you will get a detect folder, and inside that you will get a exp folder. Over there you will see the output. So let's see the output, and first see the image. Like, let's see which image is this, and then we'll see the image with the detections. All right, so let's go back here. So this is our test image. So you can see over here I've written test image.jpg, and this is the image. Let's open it. So this is the image. On this I want to perform the testing. Now let's go inside this YOLOv5 folder and see runs. Inside run we have detect. Inside detect we have exp. So I have renamed it. So exp image is this folder. Okay, so let's open it. Now let's see the output. So you can see it is detecting it as a person. Okay, so this is how you can work on image. Now let's see what's next. Next source is, see, Python detect.py. This time we are giving a video as a source. Now let's see this video first. We'll see the input video first, and we'll see after that we'll see the video with the detections. Okay, so let's go back here, and you can see this is the cars.mp4. Let's open this video. So this is the video. Now we will perform the testing. This is a short video, 10 seconds video. Okay, so now let's see the video with detections. Runs detect exp underscore video. Okay, let's see the output. Okay, this one is a, sorry guys, I have done the testing on a different video, but you can see here also that we are getting the output. Right, now let me open the another video to show you. Okay, so let me open the other video, exp2 video. Yeah, this one I'm talking about. So you can see this is how it works. Okay, so now it is working on video also. Next thing to test is source 1. This see guys, you can try source 0 and source 1 for web camera, because sometime it works with source 0 on Jetson Nano, on our normal, on our computers, right, on a Windows machine and on a Linux machine it works with source 0. Okay, for web camera. But over here on Jetson Nano I was facing a issue with, when I provide 0 as a source, at the time I was getting error. Then I provided 1 as a source and my web camera is working. So that's why I've used source 1. You can try with source 0 first. If source 0 is not working, then you can try with source 1. Okay, so when you execute this command, let me execute this command for you. Let's comment all the above codes. Okay, and then let's execute the code. So once you execute it, it will take some time and it will open a web camera, and then web camera will detect the objects. So guys, this is how you will see output of web camera. Okay, so now let's move to the next source. Our next source is RTSP stream. Here RTSP stream. So source is this RTSP stream. Okay, you can see this IP address and the password, and then this whole URL. This is our RTSP stream. Okay, now see, you can processes started, and then we were able to connect with this RTSP stream, and now it will open the camera and show you the output. So guys, you can see the output, right? So this is how it works, and now let's close it. So for that, you just need to do Q. So this is how RTSP stream work. Now the next thing is to work on CSI camera. So let's see how to use that. So for that, what I have done is, so guys, I took help from this GitHub repo. So what I have done is I have downloaded the elements folder from this GitHub repo, and I took the code from here. Okay, so download the elements folder and place it in your YOLOv5 folder. Let me show you where I have placed. This is the YOLOv5 folder. You can see the elements folder over here. Place it over here, download it from this GitHub repo and place it over here. So this folder have only one file, this YOLO. You don't need this file, okay? So this is the file we have, and then we will use the code from this file. Okay, this is the code. All right, so now let's see what we have done. So basically I just created another copy of this detect.py, and I have given a name detect_modified.py. This file, detect_modified.py file, this file will work with image, video, CSI camera, USB camera, RTSP streams. Okay, this file was not working with CSI camera, so we have added some code in it to make it work for CSI camera also. So let's see this file. So okay, let's open this file. So what we have done is, so this is the file, detect.py file. So over here, this is the code. Firstly, I have added in the beginning. So I am importing nano camera, because using this nano camera module, this camera interface, I'm using this nano camera interface. Using this interface, I will use the CSI camera. Okay, and if you don't know about this camera interface, then just install it by pip install nano camera. After that, import it over here like this. All right, and then remember we have our elements folder which we have downloaded from the GitHub repo. From this element folder, we are using a YOLO file, and in that YOLO file we have one class with the name of object detection. We are using that. Okay, so we will do the detections with this class, object detection class, and it is in YOLO.py file, which is in elements folder. Okay, and object classes, this is a list. So guys, Coco dataset have 80 classes, so these are the names of those 80 classes. And then object colors have the different colors for all the bounding boxes, and object detector variable, object_detector. In this variable, we are calling this object detection class, and we are providing the pre-trained model. This pre-trained model is trained on Coco dataset, and these are the 80 classes of that dataset. Object classes, okay, this. So we have done, pasted this over here. So from where I got this I got from this file. Okay, this file, this Jetson YOLO.py. You can copy the data from there and paste it here. After that, just scroll down in this run function, scroll down. So after this line, source equals to string source, after this line I have added this code. This code will read the CSI camera and then will detect the objects. So basically what I have done is, I have written if source is 3. That means if you are providing source is equal to 3 in your detect.py command, the way we were working with other files over here. Okay, just give me a minute. So let's say if you are writing Python detect.py, and then we provide the source. If you provide source 3, okay, and then provide the weights are YOLOv5s.pt. This is how we write the command, right? So this source 3, if you give source 3 over here, then what will happen? What I have written is Okay, where is that code? Yeah, so I've written that if source is 3, then with the help of nano camera interface, I want to open a CSI camera, and this is the line. This one line is responsible to open a CSI camera. And after that, if camera is ready, CSI camera is ready, then we will read all the frames one by one. And after reading those frames, we are storing those frames in frame variable. And then object detector. Remember, this is the variable in which we have called the object detection class. Okay, above. Dot detect is a method to detect the object, and we want to detect the object from the frames. Okay, and then with this code, we are plotting a bounding boxes on the objects which we have detected, and we have written the class names on them. Okay, so for that you can see object colors we have mentioned above. Okay, and with the help of this put text, we are putting the text on the bounding boxes. Okay, and finally cv2.imshow will show all the frames which we have one by one with the object detected on it, and with the bounding boxes and with the names. Okay, so this is the code. So now let's check this code. Okay, so let's run it. Let's come out from here, and my code is in Python examples, and then I have another folder. Inside that I have a folder, not this one, sorry, let me see the folder name. Yes, it's cd YOLOv5. Oh, it's sorry, my bad guys, 3 underscore. In this, let's see what we have. Then we have cd YOLOv5 on Jetson. Then again we have YOLOv5. Okay, so now I have entered in the folder. This is the GitHub repo we have installed, we have cloned in the beginning. Okay, I have entered in that. Over here I'll execute the command python detect. Our file name is detect modified. This is the copy of detect.py only. Okay, but this have a code of CSI file, CSI camera also, detect modified.py. And then we are providing the source should be 3, because if source is 3, then only CSI camera will open. And after that, let's provide the weights, because this will perform the detections. Okay, weight file name is YOLOv5s.pt. Okay, now let's run it and see what we get. So you can see the camera is ready. So CSI camera ready, true. That means the camera is ready. So you can see we have executed the command, and now CSI camera is ready. Now camera will open and it will start detecting the objects. So you can see the CSI camera. The output is a cup and then TV, and this is how it is detecting the different devices. Okay, so this is how we can use CSI camera and USB camera, and then RTSP streams, images and videos on Jetson Nano. And I hope this video is helpful. Thank you for watching.